All right, guys, so section 1.7 notes, we are studying absolute value functions. We are going to solve and we are going to be graphing the functions, okay? Let's start with some vocab here. And again, if you need to pause, please pause so you can write down the definition. Absolute value, students, is the distance from zero. Now, an absolute value function in the HK form, sometimes we also call this the vertex form, this is a very important one, which is y equals a times the absolute value of x minus h, close the absolute value symbol, plus k, where hk is the vertex, okay? So this is a very important equation. Vertex is the highest or the lowest point of our absolute value. Axis of symmetry is a line that divides a graph into two identical parts. Rate of change is very fancy, but that is just also known as the slope. A maximum value, guys, we are going to use the y value only and the y value of the highest point on the graph. Minimum is very similar, is the y value only, but is the lowest point on the graph. One-to-one function, student, this is brand new to us. Remember, a function was every input, which is the x value, can only have one output, which is the y value. Now, one-to-one function is even more strict. Now, in addition to that, every y value, every output, can only have one input, okay? So that's all of our definition for this page. We have some, and again, if you need to pause it so you can write, please do so. So once you're done writing, let's go to this middle column here. It says evaluate or solve the following. Absolute value, students, of 5. The distance from 0, okay? So that meant if you have an absolute value of 5, that means the distance here is 0. 1, 2, 3, 4, 5. Here's 5. That means the distance is 5. Okay. What happens when you have negative 5? 1, 2, 3, 4, 5. Here's negative 5. The distance from 0 is still 5 units. That's why absolute value is always positive, okay? Because it is a distance. In another word, since absolute value is a distance from 0, it can never be negative. C says absolute value of x is 6. This means what are the possible values of x on the number line? Always from 0, that gives us a distance of 6. So on the number line, here's 0, right? We know to give us a distance of 6, one of it has to be 6. So we know x has to be 6. But remember, a distance can also be 6 if we have an x of negative 6. So an absolute value equation usually has two answers. D says absolute value equals negative 6. This means what are the possible values of x on the number line? Always from 0. That gives us a distance of negative 6. Since distance is not possible to be negative, this is not going to ever be okay. So x is no solution because distance can never be negative. So whenever we have an absolute value and it equals to a negative number, we know right away that we will not have an answer for x. E, absolute value of x minus 2 students equals 4. This means what are the possible values of x on the number line? Because it's not from 0 anymore because we are now minusing 2 from 2. That gives us a distance of 4. Okay, so in essence, instead of from 0, we're going to go to 2. And we want a total distance, students, to be 4. So that means 1 distance, 2, 3, 4. This is 4 units from 2. So that means if that's 2, this is 3, this is 4, this is 5, and this is 6. So x can be 6, but, right, it can be the other way as well. So 1 here, 2 here, 3, 4, 5, 6. So if we label this, this is 2, this is 1, this is 0, this is -1, -2, -3, and -4. So we want a total distance to be we want the total distance to be 4 from 2. So 1, 2, 3, and 4. So here is the distance of 4 from 2. So x could be either 6, which is on the right side of 2, or x could be -2. So those are both will give us the distance of 4 units from 2. F says absolute value of x minus the -1. So guys, when you see x minus of -1, it's the same thing as this, okay? Absolute value of x plus 1 equals 3. So this means what are the possible values of x on the number line? That's going to give us a distance of 3 from -1. So similarly to the one above, we are going to start at -1 here, and we want the distance to be 3. So we can count 3 units, 1, 2, 3. So this is a distance of 3. So if you're going to go and label that, that's going to be -1, 0, 1, and 2. So the first x is going to be 2. But we could also go 3 units on the other side, 1, 2, and 3. So this is also a distance of 3 from -1. Remember this, -1. So that means if we're going to go and label this, that's going to be -1 right there, -2, -3, and -4. So x, two possible values of x, students, are either 2 or -4. Well, there has to be, students, an easier way to solve these, right? Without drawing out the number lines every time. Yes, totally is. So when we see an absolute value, let's go back to the one above. Absolute value of x minus 2 equals 4. We know there are two answers. So we take the original, the absolute value, and make two equations. First one is exactly the way it looks. Okay, then the second one, I'm going to draw this. We write exactly the way it is inside the absolute value, but we change this to now a negative. And then we solve it normally. If we add 2 to both sides, students, that's how we get the 6 right there. If we add 2 to both sides here, students, that's how we get the -2 right there. So we take the absolute value equation and we set it equal to the number on the outside. That's one equation. Then we take the absolute value equation, then we set it equal to its negative answer, and that's how we solve, okay? Now, same thing with this. We're going to take this right here. This is your starting equation. The first equation is exactly the way it looks without the absolute value symbol. The second equation, students, we take this, and whatever the answer is, we make it negative. So if we go to solve this, -1, -1, that's how we get the 2. -1, -1, that's how we get the -4.